Alright, for number 9, you're asked to factor. So remember, there's 3 different factoring methods. I'm going to go down my list. Factoring method number 1, greatest common factor. I can already look at these two numbers, 18 and 27, and know that they have a common factor, a number I could divide both of those by, and they definitely share some x's. So I'm going to be using method number 1. That was the first part of the question. Decide what method. So there is an easy way to do GCF where you can use guess and check, or you can do the sort of a longer method and where you compare 18x to the 5th and 27x squared. I'm going to do the longer method. So 18x to the 5th is our first term, and 27x squared is our second term. So I need to make a factor tree of 18 and 27 to find the prime factors. So 18 would be 9 times 2. Remember, you could pick any factor pair. 9 splits as 3 and 3, and that completes that list. 27, 9 times 3. 3 is prime, so we circle it, and 9 splits as 3 times 3. Alright, so for 18x to the 5th, in any order, its prime factors were 2 times 3 times 3, and then I need to expand 5x's for x to the 5th. 27x squared, we have 3 times 3 times 3, and then x times x. Alright, so looking at our Venn diagram, in the center where they overlap, that's our greatest common factor, what they share. So looking at my list, what do they have in common? They have a 3 in common, so I could cross out a 3 in each list and put it in the center. What else do they have in common? They have another 3, cross it out in each list and put it in the center. And that completes all of the numbers they have in common. So looking at the x's, how many x's do they have in common? Well, they have 2 x's in common, so I'm going to circle both. Cross them out in each list, and I'm going to put x to the second power to represent the 2 x's they had in common. So, what's left over, I'm going to circle that in each list. On the 18x to the 5th, we have 2 and then x to the 3rd. So I'm going to write that 2x to the 3rd for the 18x to the 5th side. And what was left in the 27x squared? Just a 3. So I'm going to write that on the 27x squared side. So now that you have your chart filled out, I'm actually going to erase so we have some room here, our prime factorization of each number. And let's look at our chart. So right now at the very middle, where it's overlapping, if you have more than one number in there, you're going to multiply them together. So 3 times 3 is 9. So 9x squared is the greatest common factor. That's always going to go on the outside. So let's rewrite the expanded form because it will help us. 18x to the 5th minus 27x squared. So the GCF was 9x squared. That was the greatest common factor. So that goes always on the outside of parentheses. And to fill out what's left in the parentheses, since the first term of the expanded was 18x to the 5th, we're going to look at what's left over in the 18x to the 5th side, which was a 2x to the 3rd. We're going to bring down this subtraction sign here from the expanded form. And then right above it is a 27x squared, so we're going to look at what was left over for the 27x squared, which was a 3. How do I know that this is factored completely, especially if you're doing this without any work? Always check to see if these numbers have anything in common, or if they share any variables. 2 and 3, there's nothing I could divide 2 and 3 by, and they definitely don't share any variables. So this is the factored form. It's completely factored, and you can always check your answer by distributing the 9x squared to both terms. So let's check. 9 times 2 is 18, and then x squared times x to the 3rd, you add the exponents to get a total of x to the 5th. And if I distribute 9x squared to the next term, 9 times negative 3 is negative 27, and then you have x squared. So this checks out.